Algebra 2 students, in today's lesson, we're going to talk about simplifying expressions. And this is the beginning of chapter 9, which deals with rational expressions. Basically, we're going to be doing work with fractions and including variables. So the key here when you're simplifying an expression is, number one, to make sure everything is factored completely. Factor everything completely using your techniques for factoring. Once things are factored completely, you can either reduce the fraction or you can cross-cancel. If you are multiplying rational expressions, when you multiply, it's top, top, and bottom, bottom. And when you are dividing, you will flip the second and multiply. So an example, if I asked you to simplify these expressions, now number one, and these are in the 9.1 practice, but number one, these are each a monomial. So it's one term divided by another term. Therefore, we would just reduce. The 9 goes into 27 three times. A squared over a to the fourth. Remember, we're dividing two numbers with the same base. We would subtract those exponents. So we have a to the negative 2. We would have b to the negative 1. And we would have, and this would basically be c to the negative 1 because that's in the bottom of the fraction. So we also have the 1/3. And now, since we have all those negative exponents, they would move into the bottom. So it'd be 1 over 3 a squared, b to the first, c to the first. The other way to do this is you could cancel. So we could take an a squared out of each of those, which leaves with an a squared in the bottom. We could take a b cubed out of each of those, which leaves a b in the bottom. Number 3, now we're talking about a binomial divided by another binomial. So typically, students will think they can just cancel these y squareds or cancel those y's, but since it's a binomial, we need to factor completely before we do any canceling. First step in factoring is to take out the greatest common factor. So on the top of the first one, I could take out a 5y, which will leave me with 2y plus 3. On the bottom, I could also take out a 5y, which would then leave me with 7y minus 1. And then these are like factors, and so this 5y now would cancel. And you're left with 2y plus 3 over 7y minus 1. If you're simplifying an expression and you're multiplying, signified by this closed dot, now we can reduce, or we can also cross-cancel. We could also multiply the top and the bottom together, but looking at cross-canceling, the 2 goes into 14 7 times. 15 and 25, I could take a 5 out of each of those. I have an x in the bottom here, which would make this an x squared. I've got a u squared in the bottom here, which would cancel and this leave me with a plain old u there. And then I can take a y out of this one, which would leave me with just plain old y. Okay, now kind of cleaning this up. On the top, I've got 5ux squared. And on the bottom, I have 3 times 7, so I have 21. I'm going to keep these in alphabetical order, so it would be y, z to the 5th. And now looking at this, nothing else would reduce or cancel. And so that would be my answer there. When you're dividing, You're dividing, now you're going to flip the second and multiply. Okay, and then I've got multiple terms here. So I've got a trinomial on each of the tops. I've got binomials on the bottom. So I'm going to factor each of these first. So this one here, I've got 2s squared, so I'm going to have 2s and s. I'm going to use 5 and 3. I need a -7, so I think I need a -5, +3. S plus 4 squared on the bottom is like s plus 4 times s plus 4. And now I'm going to flip this one. So this s plus 4 is going to go up on the top. And I'm going to factor this s squared minus 10s plus 25. If you remember, this is a perfect square trinomial. So I'm going to have s and s. Both signs are negative. 5 and 5. Now everything is canceled or factored as completely as we can. So we're going to look at reducing or cross-canceling. I can cancel one of these s plus 4s. I can cancel one of these s minus 5s. And then I'm left with 2s plus 3 over s plus 4 times s minus 5. And that would be my simplified answer there.